Hey guys, I'm with Praxair. My name is Rachel Kornick.
Oh, and Tony Tyrone.
So today we are going to talk about cryogenics and we're going to make ice cream. So we're going to go through the presentation pretty quickly, but we got to give you some background on what cryogenics is before we make the ice cream, because then you wouldn't understand what's going on, right? So we always start with safety at Praxair. It's the most important thing. So one of our principles is that you are responsible for your own safety. That's one of our core principles. So if you're walking or biking to school or to a friend's house, what things can you do to stay safe? Tell them. Wear a helmet. Very good.
Watch for cars.
Watch for cars.
Look out for any strangers.
Look out for strangers. Maybe not talk to strangers. Yeah.
Have brakes on your bike.
Have brakes on your bike. That's a great idea too.
Stay on the sidewalk.
Stay on the sidewalk.
Make sure you know how to ride a bike.
That's right. Make sure you know how to ride a bike. These are all great examples for how you can stay safe. So I had a couple. Wear a bike helmet. Don't text while walking if you have phones, or play with your video games. Don't speak to strangers.
That was me.
Take a route that a trusted adult knows about. Look both ways before crossing the street. You guys had many other examples. One more?
You can also wear pads.
That's right. That's right. So our safety principle, you are responsible for your own safety. We're saying that your parents will give you rules, right? They'll say, wear your bike helmet, or make sure that you are looking both ways before you cross the street. But ultimately, you guys will have to make that decision for yourself, right? So you are the ones who are going to keep yourself safe if you're walking to school by yourself, right? Because mom and dad aren't always there, or they won't be in the future. Does that make sense? So we have rules at Praxair, but the only way that we're going to stay safe is if we follow them. So that's how you're responsible for your own safety, and I'm responsible for mine. Make sense?
Yes.
Yeah? Okay. So today we're going to talk about cryogenics. Have you guys heard that word before? Yes. Yeah? Can we all say it together? Cryogenics. Cryogenics. Very nice. And then we're going to talk about a couple of applications of how we use Praxair gases. And what applications means is how we use the gases, so how we apply them. So what are we going to use the gases for? To make something else or to create something. And then, of course, we're going to make ice cream. Okay, so Praxair is all around the world. All of these green areas, that's where Praxair is. Can somebody come up here and, by raising hands, point to the United States? Come on up. Point to the United States. Yeah, nice job. So that's where Praxair is in the United States. And can someone point to Canada? Come on up. Which one? You got all that there? Yeah, nice job. That's Canada. So we're in Canada too. And I got a tough one. What about India? All right, come on up in the blue. Yep, that's you. Very, very close. You're almost there. Move your finger just a little left. Yeah. There you go. India. So we're in all of these green areas, and you guys pointed out some of the big ones. All right? A little geography too in your science math lesson. Okay, so our company's really big. We have like 25,000 employees. It's a lot of people, right? It's a lot more people than in this room. So we're a big company. Nitrogen, that's right. Argon. Oh, you guys are so smart. So how much nitrogen is in the air? Is it a lot or is it a little?
A little.
Okay. How much oxygen is in the air?
A lot.
Now that's what you would think, but actually, nitrogen is 78% of air. Yeah, isn't that interesting? And oxygen is only 21% of air.
And then the other one is hydrogen.
And then the 0.9% is argon, which is what you said, right? And then there's a little bit, just a little bit of other gases like hydrogen and helium. What do we use helium for? Balloons. Yeah. And it makes your voice squeaky. And so Praxair provides helium to places like Party City where they make balloons. Or they blow up balloons, yeah. And then there's also neon, CO2, krypton, xenon, in really, really small amounts. Really small amounts. So how much nitrogen is in the air?
78%.
Right. How much oxygen is in the air? 21%. How much argon is in the air?
49.
Yeah, you guys got it. Okay. So now we need to talk about numbers. I need somebody to come up here and point out the positive numbers. All right, come on up. Nice job. And now I need somebody to come and point out the negative numbers. In the white shirt right here. Yeah, good job. Okay, and when it's 80 degrees Fahrenheit outside, are we warm or are we cold? We're warm, right? Today, what's the temperature outside right now? Warm. It's cold. And like, what's the temperature? 21. And what is freezing? You're right, 32 Fahrenheit. So water freezes at 32 degrees Fahrenheit, right? So what if we go down to 0 degrees Fahrenheit? It's colder, right? What if we go down to negative 300 degrees Fahrenheit? What? That's so cold, right? Would we be able to live if we were in? Probably not. No. So that's what we call cryogenics. When you are looking at the behavior of a substance at super cold temperatures. So what did I say? Like, what's the temperature of a cryogenic thing? Negative what? About 300? Right, so maybe negative 300 degrees Fahrenheit. That's where you do experiments that are cryogenic experiments. So I just want to talk about water real quick. So we already said that the freezing point of water is 32 degrees, right? So it goes from a liquid to what? A solid at 32. And what is the boiling point? It's 100 degrees Celsius, but what is it in Fahrenheit? Close, 212. Oh, I didn't hear it. Nice job. So this is just water, but if we're talking about other substances, like nitrogen, or we're talking about oil boils at a different temperature than water does, and it freezes at a different temperature than water does. Does that make sense? So different substances have different boiling temperatures and different freezing temperatures. So nitrogen is another example. So today, nitrogen at 32 degrees Fahrenheit will still be a gas. Okay? Even though water turns into a solid, nitrogen is a gas. So today we're going to get down to super low temperatures, to negative 320 degrees Fahrenheit, and that's when nitrogen becomes a liquid. And that's what we're going to use to make the ice cream. Does that make sense? A little bit? A little bit? Okay. So this is the definition of cryogenics. The study of the production and behavior of materials at very, very low temperatures. And in order to separate air, we have to first make it a liquid. And you know how water boils? You know how water boils? Well, that's what we do. We get the nitrogen to be really cold, so it's a liquid. And then we have to, or the air, we get it to be a liquid. And then we have to boil it off. And then it separates into different components. So you get nitrogen, argon, and then oxygen. So it separates. And it's much more complicated than that, but that's the basic idea. Is you get it into a liquid, and then you have to boil off each component, and then you separate it. And so what did I say we have to cool the nitrogen down to get it to be a liquid? Yeah, nice job. It's also right here. Yeah, got nitrogen. It's on the screen. Okay, so now we're going to just talk about some of the applications. So it's Spider-Man. So they used some of our gases in the Spider-Man video, or Spider-Man movie. Isn't that cool? We had like specialty gases that made it look all foggy. And we talked about balloons. So helium we use for balloons. And we use, what do we use in the hospital?
Healthcare.
Right, that's right, it is healthcare. But what gas do we use in the hospitals? Oxygen, that's right. So Praxair makes oxygen for the hospitals. So for computer chips, yeah. And we're going to talk about some of the other ones. So these are just some examples. So what do we have here?
Pizza.
So freezing. We freeze stuff with nitrogen, right? Which is how we're going to make the ice cream today. So there's lots of ways to preserve food. What are some ways that we can preserve food? Freezing, right? How else do we make food last longer? What do we put it in? A fridge, but how else do we do it? Like what do you see in your cupboard? Boxes, yeah, exactly. What other containers do we use? Like baggies, sure. Or cans. Cans will help or maintain it. Maybe a thermos, yeah. And you can also dry foods, like have you guys ever had beef jerky? Right? So that makes it last a long time. Yeah. And you can also pickle foods. Have you ever had a pickle? Never had a pickle before? Okay. So pickles are in vinegar and salt, right?
Yeah.
Vinegar and salt, thanks. I wasn't sure. So that preserves it for a really long time. So there are all these different ways to preserve foods, but one of the best ways is to freeze it. And you can freeze it in the refrigerator, or you can use liquid nitrogen or carbon dioxide. So you can, when you freeze it cryogenically, if you see here, you have these little spouts, and it's shooting out nitrogen on this piece of beef. Yeah. And instead of putting it in a fridge, you just spray the nitrogen on top, and it basically forms little crystals inside the food. Just a second. And then it preserves the food, and it preserves the integrity a little bit better than some of the other ways that you can preserve food. The boudin? It probably could. I think you could probably freeze anything this way, but it works better with some things than other things. Yes, what's your question?
I went to an ice cream place and they got this tube and it was really prepared.
Yeah, I bet you it was nitrogen. Yeah? I've been to one of those before. They're really cool. I can't believe you didn't think there was those Praxair. Such a business model. Right. Okay, so what are two ways we can preserve food? We already talked about it. You can pickle it, right? What's one other way?
Potatoes.
Can it, right. You guys got it. What gas does Praxair use to freeze food?
Nitrogen.
Nitrogen. You guys are way too smart for this. I need to come up with harder questions. Okay, we got another one. Tony's going to talk about space. Woo!
Yes.
You have a question?
I know about black holes.
You do? We're not going to talk about black holes today, but maybe another time. Go ahead, Tony.
So launching a human into space is no small feat, right? That's got to be pretty tricky. How do you think we actually launch a rocket into orbit?
You use gas. You like gas.
Yeah, you'll use gas combined with fuel in order to provide the thrust you need, but it's basically called combustion. So combustion is when you have fuel and you mix it with oxygen. So those two things together, a lot of times it'll be, for instance, on a rocket, it's hydrogen and oxygen. Combining those two together creates a lot of heat really, really quickly. So when you create heat really fast, that's what you see coming out of the bottom of the rocket. You just point it. What's that?
Like when you mix gas and water, like gas and water.
Well, same kind of idea, right? A chemical reaction of some sort. This type of chemical reaction just creates a lot of heat very quickly. If you point it the right direction, you can use it as rocket fuel. So that's why you see it sticking out the bottom of the rocket. How we take part in that is we provide both the liquid oxygen and the hydrogen that they put on rockets. So say you want to launch this rocket, they actually take the liquid oxygen, so we take the air, we cryogenically bring it down to a liquid for oxygen and hydrogen. They put it on the rocket, and then when they're ready, they combine the two in combustion and create the thrust to actually launch a rocket out into space. What else? So the process of burning fuel, what was that called? Combustion, correct. And for what purpose does NASA use our gases?
To go to space.
Right.
Both of us will have lab coats on and cryogenic gloves for cryogenic materials, okay? The other thing is that nitrogen is an asphyxiant. So the thing is that we're not going to get too close to it for right now, but you can see the vapor is coming off, it's vaporizing. All right, do it up? Okay. All right, so what we have to start with is, actually, here, somebody can do this for me. We'll start with him. Somebody else can do it?
Yes, me. Yes,
Well,
it's
I'll-
always my lucky day.
We'll let you do something else, okay?
How much is it?
You
we're
can fill it
thinking
all the way
about
up to the
4
top,
liters.
try not to spill
It's
it.
actually a lot smaller than it looks.
It's okay
The
to spill.
inside's very thick, so that when I brought it from work to here,
Fill it all the way up.
it doesn't, if a lot of heat gets to it, it'll just start vaporizing out. So it's very, very cold in there.
Can you buy with a knife?
Okay, I think that's good.
Yeah.
Nice.
Yeah, you don't want to touch it though. Very, very cold.
No, we are not, no one's touching inside the bowl.
You'll get frostbite. Touch your foot in it, because that can just
No.
happen in 5 seconds.
You cannot touch the bowl. If you have the gloves on, but not right now, not right now.
Is this good?
All right, that is great, thank you. Okay, so it's 2 quarts, half and half. I just want to make sure I have the right one. So I'm gonna pour.
It looks like whenever you put water in like the skin, it's really hot.
All right.
That like the same thing.
What's your name, girl
Yeah, it
power?
has to do with
Hey,
the,
girl power.
let's hope
Girl
viscosity.
power. What's your name? All right, don't touch the bowl. But what you are gonna do is you're gonna pour all of this half and half in the bowl. So we'll pour it in one of these. Just do it slow.
There's another bowl inside.
You're gonna pour it all in.
Yeah, it's a
Or maybe let's do half of it, maybe. Should we just do half of it? Okay, sorry, we're gonna stop there. Sorry, thank you. So half and half. And then, can I have somebody else to pour in?
my leg.
You already did one.
Oh my god, my
There
leg.
you go. Just pour in about half of it. Okay?
Oh.
What's that little brown stuff in there?
Perfect, thank you. All right. Supports us doing this for you guys. Go ahead.
Just say I don't use it for my own.
Girls, put your glasses on. There you go. That's what I got. It's just for a minute. It's cold. The ice cream.
It feels like outside.
It's cold.